Hi, welcome to this presentation about performance tuning in Power BI. Important topic if you want to make your report run faster, appear faster for the end user, or refresh faster. All these things we're going to cover. But first, let's introduce myself. My name is Arthur Grouse. I've been working with Power BI for over the last 10 years, and last years also work a lot with Fabric and do a lot on that side. I give a lot of trainings and do coaching and development in Power BI. Let's take a look at the agenda, because there are a lot of things that we're going to cover. First, we're going to take a look at Power Query, how to make your report refresh faster. Especially if you're working with SharePoint, that can be very frustrating and slow to import files and folders. But also if you work with REST APIs, they are in general also very slow. So incremental refresh can help quite a lot. Also Queryfolding, if you're connecting to a SQL Server database, you want to make sure that your M code gets translated in SQL code. And what if you're working with direct query? That can also be pretty slow. You can use aggregations to mitigate that, and that's a nice combination, I think. We're also going to take a look at the tabular model, the semantic model. There, of course, we have the data modeling, like working with fact and dimension tables, but also looking into the storage engine, the Vertipaq. How does this actually work? How is this data compressed? And how can you take advantage of that? And also going to take a look at formula engine. How is it being used when you build DAX formulas like measures? Okay, let's dive right into it. Importing files from folder. It's a very powerful option in Power BI to import the whole folder at once. It can be a local folder or it can be a SharePoint folder. And the last one I want to talk about, because the SharePoint folder, it's slow at best. SharePoint is by itself a slow system, but if you use it from Power BI to import files, it's very slow. So let's first take a look at why is that? Why is it so slow? The problem is if you import a folder from SharePoint, you're not importing a folder from SharePoint, but because you're basically importing the whole site. That's how it appears like. So if you go here to get data and you go to more and then click on the SharePoint folder, then the first thing it will ask you, it's not a folder, but will ask you the site. And that's where the main problem lies. So let's go to, for example, this SharePoint site. Here I have some files in the sales targets folder. These I want to import. But yeah, I don't specify this folder URL. Now I go to the site. And then I put it in here. And if you click OK, then it will give you a list of all the files in this site. And normally you won't even see the files that you're interested in, because you will be overwhelmed by thousands of files. In this case, I can actually see the files because I have a small site. Okay. So the first tip I can give you is, if you want to work with folders from SharePoint, put them in a subsite or a specific site where you only have these files. And that will make it a lot faster. For example, here I created a subsite. Targets. Let's take this URL, and in this we have only one document library, and in this document library we have just the files that we need. It will be very much faster if you do it like this. So if I go here again, and then you only see the files from that specific site, and it makes more sense. So now we're going to go to transform data. So here I have my files, but still it can be very slow, maybe because you have a lot of files that you want to import, and then still it's slow because you have to process all these files. Especially if you're in development mode, I don't want to wait every time I click on something and that it's going to load all these files from SharePoint. One way to make it faster during development is by using parameters. So I'm going to create a new parameter here. I'm going to call it files to process. That's called number of files to process. So how many files do you want to process during development? I'm going to set it to a number. And for example, here I can set it to 2. Okay. So now I only want to process 2 files. So if I go here over to this query I created, these are the files I want to use. So here now I can say I want to keep rows. I want to keep the top rows. For example, I only want to keep 2 rows. So I can hard code it, but I can also refer to this parameter, a number of files to process. So if I click OK, so now it's gonna only load the first 2 files and then do all the steps. And then it will be way faster. So now I can just click on it. It's only did 2019, 2018. And if I go to the Power BI service, I can put it to an extremely high number, for example. And if you go back now, and now it's going to process all the files. And then, of course, it will be slower. But if you're in development, it will be a lot faster. Another way to improve working with SharePoint files is by using Dataflows. Dataflows basically is Power Query, but then running online in the browser. It's the same M code, everything's the same, but if you run the code, then the data will not be stored in your model, but it will be stored separately in a CSV format inside the blob storage. Azure Data Lake Storage Gen 2 actually, just like a data lake. It's like a mini data lake. Nowadays we also have Gen 2, that's more on the Fabric side, and then it will end in a lakehouse or warehouse, there the data will be put. But this is a nice way also to get started with these things. We have like a mini data lake with these files, and these files that you import here, this data, you can reuse it across multiple models. So you can import it again in all these models. And it has a different schedule. Because sometimes it takes quite a lot of time to process all the files, and after 120 minutes you get a timeout. But if you put it in separate data flows, then for each data flow you have this timeout for 120 minutes. So then actually you can do a lot more with it. So that's a really nice thing. Let me show you how it works. So here we are on the Power BI service in the workspace. There I have this data flow. It's the same logic that I showed before. In the data flow you can have multiple Power Query scripts. And here we see all this logic again. And this will be refreshed by a schedule, and then I can pick it up from Power BI. Let's look at it from the Power BI side. Here I can say, okay, I want this data. I don't want to mess with it in Power BI desktop. I'm going to go over here to data flows. And here you can specify which workspace you want to get it from and which data flow you want to take. This is the one. And inside the data flow we have tables, and I can just transform data. Or basically just load it, and there I have the data. So here it's very fast, and all the editing you do it in a browser, and that is also a lot faster than doing it in Power BI desktop. Okay, the next up we're going to take a look at web APIs and incremental refresh. The web API stands for Application Programmers Interface, and is a way to get data from software as a service application. Nowadays a lot of applications are on the cloud. They basically don't have a database anymore. So if you want to get the data into Power BI, you can use a download, or you can go with this way. You can go with a web API route. But the problem with web APIs is they're actually meant for application developers, building apps and websites, and not so much for BI people like we. Because we tend to get too much data. We want all the data, millions of rows. And the web API is not really that suitable for that. So what you basically want to do is you always want to filter the data so it's faster. So to improve the performance, what I want to show you is how you can integrate incremental refresh to make your refreshing faster. Because you're only going to refresh the data that has changed, only from the last 2 or 3 or 4 days. Let's take a look at OData. OData is a protocol with which you can filter web APIs. And it's basically just like SQL. So we have like a where filter, we have an order by, we have a select, we have a top, we have a skip. It's very interesting, but it's all in the query string. So basically we have a service route, URI, and then we have like a subpath, what kind of thing that you want to get, which entity, for example. And then we have the query string behind the question marks, and there we have all these query options. And with that you can filter, and you can also specify the range of data that you want to see. So let's dive a little bit deeper in this filter part. There's some operators that you can use, like equal, not equal, greater than, or equal. And it looks like this. So you can specify $filter equals, then the field you want to filter, and then the value you want to filter on. For now, we also want to use date ranges. Like I want to get the order date greater or equal to this date time and less than this date time. So that's the way to filter it. Let me show you how it works. So here I have a web API returning, in this case, OData orders. So now I get all the data. But say I want to filter only the data of a specific customer. So what you would do, let's copy over this URL, question mark. Then we have the $filter. And then I can specify the field I want to filter on, like customer ID. Remember, it's all case sensitive. And then I can specify equals. And then with single quotes, I can specify the value. Let's say I want to take this one. And there we have it. There we have exactly the orders of this specific customer. If you want to specify date range, let me show you that. Here I can say $filter, order date greater than, for example, date time. So now you get everything that has order date greater than the 1st of September. So this is a way to filter the web API. How can we use this in incremental refresh in Power BI? If you want to do incremental refresh in Power BI, you always need two parameters in Power Query. No matter which data source is always the same. It needs to know a range start and a range end. And these two parameters, they should change your query. Whether it's a SQL query or it's a web API query or you're getting some data from a SharePoint folder, it doesn't really matter. But this start range and this end range, if Power BI asks you, I want like the last week of data, it will change this range start and range end, and it's your job to get the correct data that matches this parameter. So if you want to do this with OData, then this range start, range end, we're going to convert it in text. We're going to format it with datetime to text, like in this format. This is the format it needs. This is the range end. And then I'm going to build up my OData filter string, OData greater or equal datetime, with this formatted string. And then in between single quotes, and then order date less than, and the same here. And then I'm going to use mcode to get the data with web.contents. I have my base URL, I have my relative URL, and then I have my query string. And this is the place where you put your OData filter. Let me show you how it works. So here I have my range start, here I have my range end. Here I have the orders incremental. Let's make it a little bit smaller range. Let's, for example, 20th. So now you can see it matches the range. If I go to the advanced editor, here you can see how the code works. So here we have this formatted parameter range start and end. And then here we can specify the filter equals this filter. And then from then on, I just JSON and I can do my normal Power Query things. So now I can set up actually the incremental refresh part in Power BI if I close and apply. If you want to set it up, you right click on the orders incremental. And here I have incremental refresh. And here I can select the table. This is the one. I want to enable it. So here on this screen, you can actually configure what you want. So I want, for example, last 5 years. So this means the last 5 years I always want to capture. If it's older than 5 years, I don't want to have it. So if the data is like 6 years old, I'm going to throw it away. And what kind of data do you want to refresh every day, for example? Maybe I want to refresh the last month every day. What happens? Every day it's going to take today minus 1 month, and it's going to put that in the range start and the range end. And that's what it's going to refresh. And that's what's going to be overwritten. That partition is going to be overwritten in Power BI. And the rest of the data will just stay the same. It's static, it will not bother with that. And every day it's going to shift. Every day it's going to take another part. And that's basically it. So you have some extra options here, but this is the basic part. And then you click apply. And then once you publish it to the Power BI service, then first it's going to do a full load, and then every day it's going to do an incremental load. And it's really going to speed up your refresh of a web API. Let's take a look at another important topic, query folding. What does this mean? If you're building a query in Power Query against the SQL Server database, for example, then all this M code that you're inserting, basically, like removing some columns or filtering some data or joining some tables, Power Query always wants to query fold it into the native language, like T-SQL or PL/SQL, or maybe if we're working on the web API, it wants to convert it into OData filter string like we saw. This is what I call query folding, translating the M code into T-SQL code. And then the query basically is optimal and it's executed against the source system, and Power Query is not doing anything at all, just like a pass-through. And then it works best. Let's take a look how this works and when it doesn't work. So let's go over here to Power Query. So here we have a query with orders. And for example, I want to join the order lines. Because there's a relationship in the database, I can just go to order lines. I can expand. And here I can say, okay, for example, I want the product ID, the unit price, and the quantity. Okay, so now basically we did the join. If you look at these steps, in the third step, if you right click on the step, I can also view the native query. And the native query means this is what's being sent over to SQL Server. So this is like the query folding taking place. So this works pretty good. And what I can do also, for example, I can do like multiplication. I want to multiply these two columns. I can do add column, and then here I can do multiply. And if you click on this step, if you right click, you can also see the native query. So the query folding takes place, and it's also doing it here. So this works pretty good. But when does it stop working? If you do things that are not supported by the query folding. For example, if I take something from the products table, maybe I take the product name, the color, and maybe if I want to split something, let's say I want to split it by a space. So I'm gonna do a split column. By delimiter, for example, space, I only want to do it once, like this. Is this being query folded? No, it's not. So now I'm out of luck. So now these steps will not be translated into SQL, and everything I do afterwards, so maybe I want to filter on extreme, then everything I do here will not be query folded. So also not the filtering of this. And even things that normally would be query folded, like filtering on the color, it will still not do it because it's an extra step here. So normally if you have these kind of things, that's not really a problem, but do the filtering first. That will be query folded, or else everything will be done by Power Query. And that's not so good. Other thing to pay attention to, what if you have used SQL? So maybe you don't use the user interface, but you just insert SQL and you do the joining with SQL. That works perfectly fine. But then, if you, for example, want to multiply these two steps, these two columns, and you do like an add column and then multiply, if you right click, it will not be query folded because it doesn't know what SQL actually is doing. So it doesn't know how to add this extra step to the SQL that you built. That's too complicated. So now the query folding will break. If you're working with Dataflows, you have this nice query folder indicator. You see at the right hand side here green or red. So that's really nice clue to see whether or not you're using query folding. To get good performance, you always want to use query folding. The next topic we're going to cover is import versus direct query. Most data sources support some kind of direct query option, like SQL Server supports this, but also a lakehouse, a warehouse, they have the direct lake option. Most proper databases have like a direct query option. which basically means is that you're not going to import anything. So it's like everything is like a pass-through. So if you click on something, Power BI is going to convert that click on a slicer into a where of a SQL statement. It's going to send it off to the database, and then the data is rendered in the report. With import, you can use all the options of Power Query. With Direct Query, you can't, because not everything can be query folded into SQL code, for example. So if you split something or you do an unpivot, that doesn't work. The benefit of Direct Query is that you basically have no model size because nothing is saved in the model. While with import, you have like this size limits, 1 GB for Pro and more if you have Fabric or Premium. You don't need to refresh because it's always real-time data that you're looking at. If you look at DAX, nowadays more or less most of the DAX functions will just work. It used to be limited, but now also advanced DAX normally works. But it's pretty slow because everything that you do in DAX, it needs to be translated into SQL code, and that makes the queries just slow. So what will be some scenarios for Direct Query? If you're only looking at small data sets and you want to have like a real-time operational report showing exactly what's happening today, then it makes sense to do Direct Query. But also if you have a very large database and you cannot import all the details, then it actually makes more sense to have Direct Query. And this is also what I'm going to show you in the demo, how you can combine this Direct Query for the drill throughs, for the details, with importing data at an aggregated level. And that's a nice sweet spot, a nice combination. Because let's face it, if you do all your reports Direct Query, they will be pretty slow and it's nearly impossible to performance tune them. You need to combine this Direct Query with some kind of import to cache the data and make it faster. So that's also what we're going to take a look at in the next demo, how to do aggregations. But first, let's take a look at Direct Query performance-wise. So this is a Direct Query report. If you want to monitor the performance, you can use the performance analyzer. So for example, here I can start recording. And now if I click refresh, it's going to refresh the whole page. And you can see all these visuals take up a small duration. Not so much in this case. But here you can see the performance penalty of the Direct Query. So 170 milliseconds. You see it also here with this one. There's also a Direct Query penalty. And what is nice about the performance analyzer is you can see for each visual what the performance penalty is. And what you can also see here, let me do it again, refresh, is that a lot of times there's also this part other. So you see the DAX query, you see the Direct Query. So this is the time it has to wait for SQL Server, and then it has to do a DAX query on top of that. And there's also a visual display, that's the rendering. But what does this 70 mean, other? Other means the waiting time. So every visual has to wait for other visuals to finish. So that's also a big performance hit. If you have a lot of visuals on your page, then the page will also be very slow. So less visuals is also a faster report. So let's see if we can tune this to make it faster. Because this is all aggregated data. So there are no details inside here. It's all per subcategory, per month. I'm not showing it per day or at the lowest level. What if I would aggregate the data, for example, per subcategory, per month, per country, and then just save that data and then import that data. And then if I want to do a drill through, like for example, I want to see exactly what's behind this one, go to drill through details, and then I would do a Direct Query for just the drill through. Then we would have the best of both worlds. So let's take a look at the model. So these are all Direct Query tables for the orders, for the products and the categories, all connected to SQL Server and the cloud. So what I'm going to do is I'm going to add the aggregation table. So here I already prepared it. So here I have, in this case it's per month. So every time the first of that specific month. Subcategory, category, we have the country, and we have the quantity and the sales. So it's all aggregated based off of this. So let's load it in. I'm going to choose import for this. So this is a table that you need to refresh every hour or every day. to get the aggregation data, but for these kind of reports it's perfectly fine. This aggregation table orders per month. It's important that you connect it to the other tables, like the date table are connected to the categories, so it's connected to the same kind of dimensions, but it's not connected to the product because it's not on the product level. So now what I can do, I can set this table up as an aggregation table. It will be a hidden table. So I go over here, and right click, manage aggregations. So this is the aggregation table, and here it detects, okay, it's the category, it's assigned to this one. Country, it's the country of the orders. Date is the order date. Line total is this line total. So whenever I use these columns from these original tables, then, and if you only use these columns, so not something else, then it can revert back to the aggregation table to get the numbers. It doesn't need to really go to the direct query data source. So this is basically it. It's pretty easy to set up. I need to hide it. So now if I go back to the dashboard, start the performance tuning again, start recording, refresh, and now if we go over here, we can see the direct query is gone. You see, it's a lot faster. Now it's still waiting for other visuals, so now the waiting part becomes more important, but it's way faster. And if you go over to the details, for example, to the gloves, I go to drill through all the details. And let's clear it up and refresh this part. Then this table, it's gonna do a direct query. Because this is details that is not an aggregation table. So it needs to revert back to the direct query. So now basically you have the best of both worlds. You have a lightning fast order dashboard on a higher level aggregation. And if you drill through, you can still go to a direct query and get all the details that you want. The most important thing about performance tuning is, as always, also the data modeling. Whether you have a data warehouse or you get your data directly from a source system, it's always best to model it with fact and dimensions. To have like a proper star schema, a data mart, nowadays they call this the gold layer in the medallion architecture, that's the best basis for your Power BI report. Everything is done in the warehouse or the lakehouse or in this data mart, and then you just suck it into Power BI and you have your fact and dimensions. I think this needs no explanation. I think most people understand how this works. So let's focus now a little bit on the relationship part and the filter direction. What's best for performance in there? Normally, if you have a one-to-many relationship, then you can choose the cross-filter direction, single or both. The best is always to set it to single. In one-to-many relationship, the filter direction is then automatically from dimension filtering the fact. That's what you want, and it's best for performance. No question about it. When would you set it to bidirectional or both? If you have a one-to-one relationship, then it's set to both automatically and you cannot change it. It's basically one table, so you could also merge the tables together into really one table. But this is perfectly fine. Another scenario where you might choose bidirectional is when you have two fact tables in the middle. Like for a master details scenario, we have an order and order lines, purchase order lines. And for some reason, maybe because you have multiple of these kind of tables that you want to connect together again, then sometimes it's better to just keep them as two separate tables. Especially if you have to really have some data in the master table, like a total or freight cost of things that are not on the line level. Then it makes sense to have them as two separate tables, but then you need to have it set to both, so you can filter through both of these tables from all the dimension that you have. So that's a valid scenario for this. In general, it's always best to set it to single. One big no is if you have many-to-many relationships, especially between fact tables. You should never use many-to-many relationships between fact tables. And you should also not have a filter direction set to both for many-to-many. Some people say it's never good to have many-to-many relationships, but I don't agree with that, because a lot of scenarios where many-to-many just fine. Just like this scenario, here I have a sales targets table. The targets are not per product level, but they are at a category level or subcategory per month. And the products, there are also a lot of products that have the same category. So this is like many to many. One category has multiple products and one category has multiple targets. And I still want to be able to filter on them. So of course I could create a separate category table to make it one to many, but that really doesn't make sense either. And these tables are normally small, like budget tables or forecast or sales targets. These are small tables. So then it's perfectly fine to have a many to many relationships between them. It would look something like this. So we connect the category of the products to the category of the targets. We also connect the product ID to the orders table. So then here we have our actual, and here we have our target, and we can just compare them together into a matrix, for example. So in this case, it doesn't have any performance penalty because the sales targets table is relatively small, and then this many-to-many relationship is perfectly fine. This is also why Microsoft added it to the product in the first place. But never we set this to both. Another thing that's better to avoid are these auto-date time tables. If you check this one, auto-date time, then for each date column that you have in your model that's not connected to a date table, it will automatically generate a separate date table with all these automatic columns like year, quarter, month, day. And you don't really need them. It doesn't make any sense. So just turn it off and then your model is clean again. Let's take a look at a storage engine called Vertipaq. In Power BI, we're running SQL Server Analysis Services in tabular model mode. And there we have the formula engine for DAX and the storage engine for the storage, for the columnar storage. The official name is X-Velocity In-Memory Analytics Engine, but everybody calls it Vertipaq. That's the code name and it's way shorter. It has a good compression ratio, like 1:10, because it's using column storage. Let's see what that is. Normally in a database, you have everything stored per row. So all the data is stored in one row, and then we get the next row and the next row. But if you want to ask BI questions like how many people live in a specific city, I actually only need the ID and the city. I don't need all the other columns, but I still have to load them in memory. In column storage, everything is stored per column. So all the numbers are here together, all the names, all the addresses, all the cities. The order of the items is the same in every storage, but they're all stored together. And because everything is the same kind of data, it's really easy to compress the data. Because we'll probably have a lot of customers with the same city. So it's easy to compress. One way to do this is run length encoding. So Power BI is going to order the data so that it can be compressed as efficiently as possible. For example, if you have a lot of Q1s, it just has to track like the first position and then how many rows do you have for Q1, and then the second position 311, how many rows do you have for Q2, and then inside that ordering we have product ID 1, 2, so here we have like 5 1s and 3 6s and so forth. So this has a very good compression ratio, this a little bit less and this not so good. Maybe because the prices are so different it cannot compress it at all. Another trick it does is using dictionary encoding. So instead of storing Q1, or for example a city, New York or London, it's going to put it in a hash, a dictionary, and it's just going to use this 0, 1, 2, 3. So that's what it's going to store. Not the value itself, but the hash. Together with the part that we saw before, the run length encoding, you also get a pretty decent encoding already. But on top of that, it's also going to take a look at numbers like fixed decimals or whole numbers. If you have a very big number, then it should use a lot of bytes to save it. But what if you could subtract a high number from this? Let's say in this case, I'm going to subtract this number. Then the numbers will be way shorter and you need less bytes to save it. So that's also a nice trick that's called value encoding. Let's take a look how that works in action. For example, here I have an orders table, and maybe you have noticed sometimes if you open up a table that the ordering can be pretty strange. For example, here, how is this orders table ordered? It's not ordered the order ID, which would make sense. But if you scroll down, you can see, okay, the quantity is the same and the product ID is the same. So one of these columns, here you see. So it's first ordered on a quantity ID, and then it's ordered on the product ID somehow. So probably this column has the highest compression ratio. If you want to see this, you can use external tools like Duck Studio, and it can really see which column is compressed how much. So this is a very insightful tool. If you go over to Advanced View Metrics, then you will see the orders table is the biggest. What is the smallest column? Quantity, and then product ID. You can see the size of the column. And what is the biggest column? It's age. Here you can see, because it has such high precision, it's difficult to compress. Okay, let's take a look at other table like customers. Here you can see the age, region, and country are very, very good compressed. Even if the country has a lot of text, it's still compressed. And this age category, this has a very low compression. Why is that? Let's see what that column is. So here we have just 3 values. You would say 3 values, that's perfect for compression. So why is it not compressing? Because this is a calculated column in DAX. And this one is not used for run length encoding. It's not a candidate because it's done after the saving. So that's also a downside if you're using calculated columns in DAX, then they're not compressed that efficiently. What if I would do this age category calculation in Power Query, like I did in this table? Now what you see is being ordered by the age category and the age. What does that mean? If I look here at the customers tuned, you see it's a lot smaller actually. It's like 1/4 of the size of the total table, the original table. And now you see the age category is among the smallest columns. Yeah, just simply doing the calculation in Power Query works better for compression than doing it with DAX. Okay, so let's look at some performance tuning tips. So you can see the compression with the DAX Studio, that's good. Remove any unnecessary columns because they'll take up space, and that really slows down the Vertipaq engine. Disable all these out-of-date timetables that we showed before. If you have high cardinality columns like GUID or date and time, it's really difficult to compress these. So it's better to split the date and the time in separate columns, like date, hour, minute. And create calculate columns in SQL Server or Power Query, not in DAX, because then they will not be compressed. The last part of performance tuning, we're going to look into DAX. If you create a DAX measure and it will be evaluated, and then 2 engines will be involved, the formula engine and the storage engine. So the DAX comes in, then the formula engine will look at it. It can handle very complex expressions, but it can also be extremely slow if you do too much in the formula engine, because it's single threaded. It can only do one thing at the same time. On the other hand, the storage engine is multi-threaded and it can look up a lot of things at the same time and is lightning fast. But it can only do simpler calculations, like look up a specific value or a specific range, but it cannot handle complex expressions. So what you'd like to do if you do a DAX measure, you want to use as much as possible the storage engine. Especially if you use like a calculate function, then if you use it the correct way, the storage engine will be fully used and is lightning fast. But instead, if you use, for example, the filter function, then it will not be used as efficiently because the filter function is using the formula engine and is single threaded, but it can handle very complex filter expressions. Let me show you in the demo what the difference is speed. So if you look at 2 different measures that do basically the same, I'm going to calculate the number of orders and I'm going to filter. I only want to calculate orders that have a quantity greater than 1. If I do exactly the same measure like this without the filter, you'll see this one is using the storage engine fully, while the one with the filter expression is using the formula engine, and it's much slower. Let me show you. First, I want to set up the performance analyzer so we can see the difference in performance-wise. I'm going to click Start Recording, and then I'm going to switch over to this page. On the left-hand side, you see the filter. being used. On the right hand side, the calculate without the filter, and immediately you can see the right one is already finished, while the left one is still busy single-threadedly working through all these different rows. You see the difference? It's mind-blowing. If you would really want to see this difference between formula engine and storage engine, because now you see the difference in timing, but you cannot really see what's happening, then you could copy this query, and then we can run it in the Docs Studio. So if you go over to Docs Studio, and I already opened up here for us to look at. So the first query with the filter is executing 3,700 queries to the storage engine. It takes up a lot of time in the formula engine. In total is 11 seconds. And if you look at the second query without the filter, it only has 2 queries. And it can immediately execute the query to the storage engine, and it's lightning fast in this case. Let's also take another example. This is a more complicated DAX formula. What makes it more complicated is this calculate is doing count rows. That's a simple operation. But here it's doing like less than and a greater than. That is perfectly fine for the calculate. It doesn't need to use the formula engine for that. But this one, the or with the is blank, the or, that's a complex expression. Because this is a complex expression, it will be much slower. If you look at the results of these 2 queries in the performance analyzer, and you see it's a much slower. The difference between the 2 queries is not as much though. It's still a lot faster without the filter, but you see this one is also pretty slow. Why is this the calculate still faster than the calculate with the filter? Let me show you. So this is the one with the filter expression. So this is being evaluated single-threaded, which is very slow. If you look at this one, the calculate, then actually this expression is causing problems. That's why it's so slow. So we could tune this by eliminating this is blank. For example, by replacing the ship date blank by, for example, today. So that can always have like something like in between. This one is a separate expression, and this one is still fast. So that's why it's faster than the filter version, because this is still being evaluated by the storage engine in a fast way, and this is what makes it slow. Okay, to wrap it up, if you want to look at some performance tuning tips in DAX, it's important to have not too much visuals on the page because of the rendering, which is single-threaded, or otherwise you have a lot of these other waiting times. Use the performance analyzer in DAX Studio together to see where the bottlenecks are, how many queries are executed against the storage engine. Use variables as much as possible, because then you don't have repetition in your DAX formulas. Because if you use a variable, then it's only evaluated this code. Its variable is really used. Avoid this filter function as much as possible. Best not to use it inside measures, because it really slows it down, as we've seen. Also, if you use a lot of iterator functions like a sum x and average x, this can also be very slow. So then sometimes it's better to just use a calculated column to pre-calculate something, like a line total, which is the quantity times the unit price, and then summarize that. Then you don't need the x function, the iterator. With that, we have come to the end of this presentation. Hope you find it useful. Thank you for sticking by till the end. You can find the demos and the video and the samples at the link here, fabriccode.com. And please feel free to reach out to me via email or LinkedIn if you have any questions.